So for this lesson, guys, this will finish chapter 6. We already did everything that we needed to do with systems, from solving it by graphing, substitution, and elimination. And we went from there into linear inequalities, from there into systems of linear inequalities, right? Now I'm coming back to this one because I don't know if you guys noticed I had skipped lesson 6.4 on your text. Some of you noticed, some of you didn't. So I placed this one at the end because now you're going to see a couple things a lot easier than if I would have introduced it at the beginning, okay? So check this out. So for today, our objective is I can solve systems of linear equations by graphing, substitution, and elimination. And like I said, we already did this. Okay, so today shouldn't be any different from what we've done in the past. The only thing today is that we're going to give each system a name. Do you understand? These names, graphing, substitution, and elimination, are not names of systems. They are methods to solve the systems, right? So check this out. Let me just do a quick glance back at what we saw in the past. When we introduced systems of linear equations, I gave you guys examples on examples. We know that it's two or more linear equations, they have to have the same variables, right? From there, we went into graphing, and I said the most important step for graphing is solve for y. Remember that? From there, I said we're going to get into another method of solving called substitution. For substitution, I said the first step, you need to make sure you solve one of the equations for one variable, and then from there I gave you guys the rest of the steps to substitute that into the other equation, and so on and so forth. Remember that? And I even said I'm going to do some mnemonics for this one, and I showed you how to do like the think and the substitute and stuff like that. Remember that? From there we went into elimination. In elimination, I said the most important step is the very first two. You need to change them into standard form, and then from there eliminate one of the variables. Remember that? And then I said the last three steps should look about the same as what we did in substitution. And I said circle stuff, underline stuff, and so on and so forth. However, today I want to make sure you understand the names of the systems. So copy these down, please. Consistent system and independent system. Consistent system and independent system. On your note side. Consistent system and independent system. What is a consistent system? Well, what was the first thing we did? We solved a system of equations. What did we come up with at the end when we solved a system of equations? What was it? You found out right now with number 4 on the warm-up. What was it? A point, an ordered pair. And what did that tell us? That it's the point of intersection of the lines. Therefore, a system with only one solution, which means one ordered pair, a system with one solution is called consistent and independent. Consistent and independent is a system with one solution. So, if a consistent system is a system with one solution, inconsistent system is a system with no solutions. An easy way to remember these guys, check this out. You're like, Mr. Q, how am I going to memorize this? Well, think of it like this. People that are consistent with their homework, they should have the solutions. However, people that are inconsistent, guess what? They will not have solutions. Is that a good way to remember? Yeah, right? So a consistent system is a system with one solution, and like I said, this one is also called independent system. It's a system with one solution. So this is this one, dependent system, a system with infinite solutions. A system with infinite solutions. So you're saying, so we're looking at 4 different systems? No. Everybody look up. Do you notice that consistent and independent are the same one? And we've been doing these, right? We solve a system of equations by graphing, substitution, and elimination, and we come up with one answer. Is that correct? So today, I'm going to show you what an inconsistent system looks like and what a dependent system looks like. So those two pieces. Okay? All right. Any questions so far? Are we there? Hands if you need more time to copy. Okay? 30 seconds. Focus, please. So, like I said, these two, consistent and independent, are the ones that we've seen that only have one solution, right? And what do? We get an ordered pair. At the end, when we graph them, is where both lines intersect. Are we there? So therefore, let's look at these two. So I'm going to give you an example of an inconsistent system. Copy this down, please, on your Cornell notes. Example 1, right? Solve y equals x minus 4 and negative x plus y equals 3. Y equals x minus 4 and negative x plus y equals 3. And like I said, we already know how to do these. I'm just going to walk you through them. We're going to do them together. Yes? Here he goes. So first of all, looking at it, which method will be the easiest to use to solve that system? Everyone. Substitution. Why? Because this one's already solved for y. What is y? X minus 4. So on the second equation, I'm going to substitute this in here. So this is x minus 4. I bring everything else down, the plus, the negative x, the equals, and the 3. From there, next step is to do what? Combine like terms, yes? What is negative x and x? 0. These cancel, it's a 0 pair. What do we have left? Negative 4 equals 3. Is this true? Therefore, no solution. What kind of system is this? Inconsistent. Very good. That's simple. This was inconsistent. Look at your notes. Which one is the one that does not have a solution? Inconsistent, right? So now, in order for you to make sure you understand it, all I want you to do is see the graph. So get your graph paper in front of you. I want you to copy these two, the system again. You don't have to copy all this work. Just copy the system first. Let me get my graph paper in front of me. Yeah, any graph. It's up to you. Let me get my graph. There it is. I know, technology, right? Bam. All right, here we go. So, if I was to ask you to graph this, what is our first step, everyone? Solve for y. So I'm going to look for the equation that isn't solved for y, which is this one. And I'm going to write it here, negative x plus y equals 3. And what is my next step? Everyone? I know, solve for y. What do I do? Add x to each side, and we're left with y equals x plus 3. Let's graph this one, and I'm going to graph that in blue, for those of you that have your pens. So I start with my y-intercept, which is 3. So therefore, this is 3. This is right there. And what is my slope? 1 up and 1 to the right. 1 up, 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 1 to the right. And I'm going to graph that in blue. Make sure you extend your lines all the way through. Okay, I already graphed the first one. Now let's graph the one that was already solved for y. What information do I need to get started? Negative 4, which is my y-intercept. So I'm going to go to negative 4. There it is. What is our slope? 1 up, 1 to the right. 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 Let's graph that one in red. As soon as you see it, don't say it out loud. Let people think. Okay? Some of you already saw it, right? Yeah. Okay? Tell your neighbor why this is an inconsistent system. And what name do they have if they don't intersect? Parallel. So then I want you to write here parallel. So whenever you find out that a system has no solution from this point forward, I want you to write all this. Everybody look up. You write no solution, inconsistent, therefore they are parallel. Pretty simple? Yeah, right? Yeah, some of them were like that, but with the inequalities. Yeah. No, but some do overlap, right? Yeah. All right, so, and if you would have noticed, everybody look up, notice that this one has the same slope as this one. What is the only thing that differs? The y-intercept. And what did we say in the past for parallel lines? Same slope, different intercept. Do they have the same slope? Yes. Different intercept? Yes. So that's what we call a no solution, inconsistent, or which are parallel. Okay? So now we already have an example of inconsistent. Now, which one do we need to see an example of? A what? Dependent. Dependent. So let's go back to our Cornell notes. Write this down. Example 2. Example 2. Example 2 says, solve y equals 3x plus 2 and 3x minus y plus 2 equals 0. First, we're going to do this, work it out first, and then we'll see what it looks like on the graph. So check this out. What method? Substitution. So check this out. The first one says that y is 3x plus 2. So on my second equation, instead of y, I write what? 3x plus 2. But be careful with these. Remember, when it has a negative sign or a coefficient, you need to open a parenthesis. So this one is 3x plus 2. And now I can bring down the negative sign. The 3x plus 2 equals 0. So let's see who remembers from when we did a lot of this practice on warm-ups. What happens to everything inside of the parenthesis when there's a negative?
They
Change to their opposite. So this becomes negative 3x minus 2. Bring down the plus 2 equals 0 and bring down the 3x. Yes, sir? Yeah. From there, let's simplify. Can we combine like terms? Yes, 3x minus 3x, they cancel. Negative 2 plus 2, they cancel. So we're left with 0 equals 0. So think about it. Aren't these identical? So let's think back to when we did equations. Whatever equations. Whenever we had something that was identical to the other, what was that called? Identical. It was called what? An identity. So therefore, what is the solution? X equals all real numbers. Bam! All real numbers. So therefore, if it's all real numbers, and this one, notice this one is identical to that one. So therefore, this one is called a dependent system. Does everybody get it? All right, good. So let's see. If that's what we found out using algebra, now let's look at the graph. Get your graph. You can use any graph you want. Let me get my graph in front of me. Let me cut it out from here. Yes. Okay, here we go. All right. So, what's my first step to graph? Which one of these needs to solve for y? The second one. So I'm going to rewrite it over here. 3x minus y plus 2 equals 0. Now look at it. Should I get rid of the 3 and the 3x and the 2, or just the y? The y. So what do I do? Add y, add y. We're left with 3x plus 2 equals y. So let's graph this. I'm going to graph this in blue. So what information do we need? Our y-intercept, which is 2. So therefore, that goes right there. And my slope is 3 up, 1 to the right. 1, 2, 3, 1 to the right. 1, 2, 3, 1 to the right. 1, 2, 3, 1 to the right. I'm going to sketch that in blue. Once again, make sure this one that you're sketching in blue, it goes all the way through. Hey, I just rhymed. Yay. All right. Everybody there? I know, right? Yeah, you guys should see me in Christmas wrapping tamales. All right, here we go. All right, here we go. Everybody look up. Okay, yes. So check this out. I graphed this one, so now let's graph the top one. Let's see. I'm going to do that one in red. What is my y-intercept? 2. There it is. What is my slope? 3 up, 1 to the right, 3 up, 1 to the right, 3 up, 1 to the right, 3 up, 1 to the right. Let me graph that in red. What did we just find out? It's the same, or it's identical. So check this out. But this is what I want to. This is what I want to convey to your attention. When we have, everybody look up, please. Check this out. When we have another type of system, and it does this, how many solutions do you see? 1, which is that one, the point of intersection of the lines, right? And then we saw that parallel lines do not have a solution, right? But this one, check this out, this one we said it's called a dependent, and we just found out that the lines were identical, or the equations were identical. Look, 3x plus 2 equals y, y equals 3x plus 2. So therefore, what does that tell you? What happens to each of those points that it's passing through? They're solutions, right? How about any point in between? They're still solutions, right? So what does that tell you? That dependents have an infinite number of solutions, right? Yes. So therefore, what do we call these? Dependent system. That means that they are identical. Identical. Yay. See what I did right there? It's the spirit fingers on 3. 1, 2, 3. Anyways, any questions? Focus. Any questions with a 3 different systems? The first system that we always solved for was dependent and what? I'm sorry, independent and consistent, right? The second one with no solutions is inconsistent. And the last one is called dependent, which is identical, right? Any questions with these? And pretty much that's wrapping up chapter 6, okay? However, once again, your homework for this weekend, here it goes. And I'm recording this so that it can be up on the web in case you need to go revisit the lesson. Your homework for this 3-day weekend, you need to go to the YouTube channel. Go to the YouTube channel and look for, type in Mr. space Q apostrophe S space UCS space M HLCM. Watch the video, the one that's 30, I think it was 36 minutes, is that correct? 33 minutes? And then you go to the, once you finish that, take notes on that, you go to page, what's the page for the homework? 41, numbers 1 through 43, odd. Okay? So, that's the homework for the weekend. Enjoy it. See you guys Tuesday.